The ctrlX drive DC-DC converter works together with ctrlX drive power supplies, converters and inverters sharing the highly efficient drive system DC bus. The DC-DC converter can be used with energy storage and buffering devices such as batteries and supercapacitors, as well as DC supply for electric drive systems or move other DC energy into the AC grid via the drive system DC bus. This table provides an overview of available ctrlX drive XMV2 units. Each application must be reviewed regarding grounding, voltage and current ranges. Consult Bosch Rexroth and refer to the documentation for more details. The demo system uses a resistance load, operated at user set voltage in the range between 20 to 275 volt DC. In this example, the ctrlX drive regulated power supply XVR2 is supplied from an isolation transformer with a grounded TN AC grid of 240 volt AC. This allows the user to choose the DC bus voltage in the range between 400 to 750 volt DC to best meet the application requirements. The DC-DC converter XMV2 provides 80 ampere and connects to the smoothing choke XLL. The XLL output is connected to the smoothing capacitor XLC where the DC output voltage is measured with a high voltage transducer for closed loop control by the XMV2. Additional fuses, contactors and measuring sensors suitable for the DC output voltage range may be required for the application. In this demo example, the system is controlled with the ctrlX core and the suitable apps. The S20 type IO, the control safety and all ctrlX drive units are controlled with EtherCAT bus. The demonstrator's HMI is web-based. It is created with the app WebIQ and can be displayed with a web browser available in stationary or mobile devices. Now we review the demonstrator setup. Then we operate the DC-DC converter with a resistance load, which is a visible halogen light. From left to right, the system starts with the line filter XLI, regulated 48 kW power supply XVR. A single-axis drive inverter XMS, then a DC bus capacitor XLC. And a 80 ampere DC-DC converter XMV2. Note, the component installation in production equipment depends on the application, and may have to be different than in this demonstrator. Here we see the smoothing choke XLL wired to the DC voltage smoothing capacitor XLC. The high voltage transducer measures the DC output voltage for closed loop control. Depending on the DC-DC application type, a filter capacitor HAS04 and a discharge resistor for the DC smoothing capacitor is required. In this demonstrator, the DC fuses and DC contactors are in a separate enclosure. In example 1, we connect a 1000 watt halogen light and operate it between 20 to 250 volt DC. Let's operate the system. The line voltage at the supply XVR2 is 250 volt AC. This results in a DC bus voltage of around 400 volt DC, unless set to the application-specific value, up to 750 volt DC. At a DC bus of 400 volt, this 80 ampere DC-DC converter can provide these output ranges. For the halogen light, we set the DC bus to 400 volt and allow a DC output voltage between 20 to 250 volt. The halogen light is connected, and we are ready to operate the DC-DC converter. Since the halogen light is for 230 volt, we can leave the DC bus to around 400 volt. We switch the XVR2 power supply on, and can see the DC bus charge up to about 400 volt. Now we select the DC-DC converter screen. On this screen we see the DC bus voltage, the DC-DC output voltage command and actual value as well as DC output current. It is also possible to operate with current command. The XMV's computed DC output power is also displayed. We can control the DC-DC converter command value for the DC output voltage. When we enable the DC-DC converter, then the actual DC output voltage follows the command. Switching the DC contactors on, connects the load and shows the halogen lights illuminate. We can control the light intensity, for example by reducing the command voltage, or by increasing the command voltage. Let's minimize the output voltage and switch to current control. Caution: in the current command mode, the DC-DC converter increases the output voltage until the actual current equals the commanded current, or the voltage limit is reached. It is hard to command 4 ampere current, and we can easily overload the light's operation limits. Let's switch back to voltage control. In conclusion, we must always set proper limits before using current control. Back in voltage control, we can easily control the power to the load, the halogen light. We switch the DC contactors off, and for the next example, we connect a 3.4 ohm resistor, with these peak and continuous load characteristics. With this resistor we can draw 80 ampere at an output voltage of 275 volt. For this test, we limited the command voltage to 275 volt. And the current command to 80 ampere. Now we activate the DC-DC converter. And set the voltage to about 220 volt. We connect the load and can see an output current of 65 ampere and 14.3 kilowatts power. We switch the DC contactors off and activate current control with a command value of about 23.8 ampere. When we switch the contactors on, we see 23.8 ampere at 80 volt and 1.9 kilowatts output power. If we increase the current to 80 ampere, the voltage goes to 271 and output power to 21.7 kilowatts. We switch the DC contactors off and let the resistor cool down, and disable the current control. Back in voltage control we can change the output power easily one more time. We switch the DC contactors off and will connect two 3.4 ohm resistors in parallel. We could expect that the resulting 1.7 ohm resistor will require at 80 ampere about 136 volt. For this load test, we can lower the DC bus voltage to around 400 volt. We select current control with a command of 80 ampere. Let's enable the DC-DC converter. The initial voltage is around 400 volt, since we are in current control and no load is connected. With the load connected, we see a current of 80 ampere, around 136 volt and power of 10.8 kilowatts. Now we switch the current control off and increase the voltage command to reach 80 ampere. As expected, We see about 10.8 kilowatts at a voltage of around 136 volt. We switch the DC contactors off. Now we examine the discharging of the DC smoothing capacitor. The DC smoothing capacitor can hold the last voltage for a long time. If only a high ohm resistor in the filter capacitor kit, or no resistor is used across DC plus/minus. Activating a discharge resistor can shorten this discharge time, before user access is allowed. This concludes our review of the DC-DC converter XMV2-W0080 ampere and resistance load. The ctrlX drive DC-DC converter XMV2 can be used in many other energy use cases. To review your DC-DC converter application, please contact in the USA 1-800-REXROTH. Thank you for watching.